The simplest depth gauge is basically a glass upturned in the water with air trapped inside. This is a capillary depth gauge. The airspace will become smaller as you descend. That's Boyle's law again. If you mark the glass by using known depths, then you will be able to tell how deep you are when you dive with it on your next dive. The problem is that because the pressure differences get smaller as you get deeper, they are less accurate the deeper you go. The markings get closer together. Capillary depth gauges come in handy when diving at altitude. Because of the lower surface pressures at altitude, you must plan your dive as if you're going deeper than you actually are. A capillary depth gauge calibrated at sea level will indicate that you're deeper than you actually are when you're on an altitude dive. It reads approximately the theoretical depths that you work out with altitude tables. How does this work? Well, the pressure at sea level is 1 bar, and the pressure at 10 meters of seawater is 2 bar. 1 bar for the water pressure and 1 bar for the surface pressure. The pressure at 10 meters of seawater is twice as much as it was at the surface, so the airspace in the gauge will be half as big, and the gauge will read 10 meters. But let's say that you're diving in a mountain lake, where the air pressure at the surface is 0.5 bar rather than the 1 bar that it is at sea level. Now at 10 meters, the pressure will be 1.5 bar. 0.5 bar for the surface pressure and 1 bar for the water pressure. This means that the pressure is 3 times as much as it was at the surface. At the surface it was 0.5 bar, and now at 10 meters it's 1.5 bar. Therefore the airspace will be 1/3 of the size. The gauge will read 20 meters when you're at a depth of 10 meters. Another type of depth gauge is the open or closed Bourdon tube. This is a flexible tube in the shape of a C, which contains gas or a liquid that is in contact with the ambient pressure. The higher the pressure, the more the tube straightens, and the tube is connected to a needle that indicates the depth. In a closed Bourdon tube gauge, the tube is protected from the water with a barrier of oil or a membrane.
Today, many people use digital depth gauges. They are extremely accurate. They contain a transducer. A transducer is a small piece of porcelain with air bubbles in it. Porcelain does not conduct electricity, but bubbles do. And the deeper you go, the more the bubbles are compressed, and the less electrical current is conducted. A small electrical current is put through the transducer. How much is transduced is displayed as a digital depth reading.